Okay, afternoon, ladies and gentlemen. Welcome to the Wednesday lecture. Today we're going to start and finish lecture 2. Just a few things for notice or announcements. You still needed a design for Prac 2. You don't really, if you aren't using global variables, you don't need variables. You won't have a record structure. You need test data just to prove that your code is giving the correct result. The algorithm must be done. But one thing I want to point out, any prac questions, leave them for the tutorials, please. We're trying to avoid what happened on the previous lecture where I know we had to do the misconduct video, but we spend more time discussing the practical than doing the lecture, which can cause problems. So from now on, as mentioned in the tutorials, if you have questions about the practicals, keep them for the tuts. There's still a tut tomorrow, a tutorial tomorrow afternoon, so there's time for questions there. I'll view questions unless they are pertinent or related to what we're discussing. I'll answer them. If they're not related to what we're discussing right now, I'm going to skip over them for a bit. I want to try and focus on finishing off the more important sections, and I'll come back to questions. But if your question is about understanding a concept, feel free to ask it. I'll explain something again. I don't mind. But I do want to try and finish today's lecture. Please also, just a reminder on the Informatics 1B Discord server and even the assistance Discord server, make sure your nickname is your student number. So actually this is what I wanted to do anyway. So let me just, hopefully I'm not violating any POPI acts or whatever the hell I can get calls for. On the server, just right click and go change nickname. Okay. Also, when you want to speak to your assistant, if you're in group 2, there is a text channel and a voice channel. If you click into the voice channel, you activate that voice channel. And then you can speak to the assistant in the voice channel. And then you can disconnect. So here we have mute. Someone's just joined me in that channel. I'm getting out of that channel. You have mute and deafen. So make sure that you are comfortable with Discord. We will show you a bit more of Discord in the tutorial tomorrow or at the end of the lecture if we have time. But today I want to focus on the introduction.
It seems like Mr. Cottrell's connection just timed him out. Okay, so we'll just wait a moment for him to come back. In the meantime, let me just open up the slides.
I'm back.
Ah, okay, I see you're back.
Okay. Learned a nice thing. Never press F5 when you're in Blackboard Colab. Don't ever press F5. You immediately kicked out the session. Okay. Okay, it is recording still. Live and learn, live and learn. So we have the general knowledge, which is still grammar COBOL. So today's purpose, as we ended off last year's lecture, is what is object-oriented programming and why OOP. So why are we looking at object-oriented programming? So I've updated the slides. A lot of this is going to be repetition, but I think repetition may be good. So if you've downloaded the slides already, I updated them this morning. I have got the links to where I got this information, etc. Okay. Apologies for the dogs if you can hear them. OOP is a programming model that organizes software around data or objects rather than logic and function. So instead of looking at functions and logic, we look at data and objects. We try and create a way of referencing a real world object in a digital format. An example, how would you explain your cell phone to a computer? Can you explain the concept cell phone, chair, table, desk to a computer? Step by step. But what is a chair? What defines a chair? Okay, let's Shape, good. Bit by bit. Let's look at the next statement as well. Okay, here we go. I'm getting better comments now. Good. Some of you may be getting the idea. An object is defined as a data field of unique attributes and behaviors. So attributes are the data. 4 legs. The behavior, what it does. Okay. Since my dogs are barking, a dog, how do you define a dog? A dog is a gender, a breed, a color, an age, etc. Its behavior, bark, make noise. So we try and define size, animal. Okay, we try and define something in the real world in a digital situation, and that is an object. Okay, so an object is, and how you make objects we will discuss tomorrow. Today is just the theory of OOP and why it's beneficial. So OOP focuses on objects that developers want to manipulate. So we want to manipulate the objects. We want to be able to pass the objects around in the code and use it to manipulate rather than the logic. So we want to manipulate this object. It's a very solid way of programming. The approach is very good for large, complex, and systems that need to be updated and maintained. OOP is a very common way of programming because you can define most things as an object. This allows you to function correctly and work correctly in the environment. So instead of passing around subsections of code, you pass around objects. So an object is a structure on steroids. Okay. So an object has both attributes, data, and methods. So it has functionality. That's the most important thing. And we're going to get there tomorrow as well in the lecture when I show you how to make your own object and your own class. Right now I'm speaking about objects, but something that goes with it is a class as well. Okay. So the first step in OOP is identifying what you want to manipulate, what object you want to manipulate, and then how they relate to each other. So objects also relate to each other and link to each other. So you can define a car as an object, but inside a car there's many other objects. An engine is an object, the chair is an object, the passenger is an object. Yeah, Mrs. van der West has answered the question, does objects have subroutines? Yes, but they're referred as methods. Methods and well, what's the right word? We'll get there. Methods and accessor methods. Objects aren't typically members of classes now. Okay, we'll explain the difference between classes and objects right later. A class is a blueprint or what defines an object. An object is an instance of a class. We'll get to that later. So another definition, it's a programming principle paradigm based on the concept of objects. An object consists of data, attributes, and properties, and code such as methods. Okay, so I've gone through various different definitions or ways of defining OOP objects. So you guys can try to get a better grasp of what this is. I know it's very in the air right now because I'm talking about something you haven't seen before, but it'll make a lot more sense tomorrow's lecture as well. Today we're just discussing the concept of OOP and why is it useful. Features of objects is an object can modify its own information. So with the method an object has, it can manipulate its own information. An object can calculate its maximum. An object can calculate a total. An object can calculate any value or manipulate values. I have a raised hand. You can ask a question. Got a couple raised hands. Okay, lower the hand. Okay, I still got a raised hand. If you want to ask, you can ask. Okay. A programmer designs objects that interact with one another. That's what we're going to discuss as well. So objects aren't just something that is designed in a isolated environment. Objects are designed that they will interact with each other. And oddly enough, you guys have been making objects since the beginning of the year. You've been making classes since the beginning of the year. You just haven't been told what they are yet. Your form. Every week you make your form. Remember, what is after option strict, option explicit, option infer? What is the next line of code? Public class. Public class, okay? That class is the blueprint for an object. So when you run your project, you actually are creating an object, if that makes sense. So your class that you've been programming up until now is the blueprint of an instance of an object. And hopefully that'll make a bit more sense as we go through this information. Okay. Some of you may have worked with procedural programming. Procedural programming is about writing procedures and methods that perform operations in like a linear format. Object-oriented programming is about creating objects that contain data and methods. Okay, which question? I'm not sure which question I asked. The question I did ask was, what is the line after option infer, option explicit, option infer off? I got the same hand raised. You can put your mic on and ask a question if you want.
Yeah, can you hear me now?
Yes.
Yes, I just logged in now. I saw public class. So I'm just asking what was the question, sir?
What have you been making the entire semester? Last semester, what were you making? What is that line of code there?
Line of code.
Yeah, you're making a public class every
Yeah,
week.
yes.
Yes, that's the question.
All
That's
right,
the
thanks.
question. Okay. Okay, so object-oriented programming is about creating objects that contain data and methods. So like your record structures just contain data. That is not really useful. We want to start creating a system where the data also has methods that can act on the data that's there. So we're going to have the data and methods built into our objects. So that's also part of it. Advantages of object-oriented programming: it's faster and easier to execute, provides clear structure, helps keep the code dry so we don't repeat. Objects are easy, maintained, modified, and debugged. Once you have a properly designed object or class, let me actually say that, it's easy to modify and improve a class and then export the class to another program almost. So classes can be shared between code, which makes it a lot more useful. Reusable applications, code, shorter development time. So OOP makes it a lot more reusable applications. I know a lot of this is going over some of your heads. I understand that right now. Don't feel bad. Don't worry about that. It'll make more sense when I start showing you how to make a class and what a class actually looks like. Because right now I'm just talking about objects and classes, but it's just like, what the hell is a guy smoking? So just bear with me. Right now we're just discussing OOP and the benefits and why we use OOP. One of it is it's reusable. Okay, principles of OOP. There's 4 principles of OOP. We're only going to discuss 2 of them today. Abstraction and encapsulation. Inheritance and polymorphism we're going to discuss later. I agree, it's easy to see the implementation. That's going to be tomorrow's lecture. Tomorrow's lecture, am I right to say tomorrow's lecture? Yes, tomorrow's lecture in the morning will be implementing a class. So today is theory, tomorrow is implementing. Okay, since we only have 45-minute slots, we've got to make the best use of what we have. Right now, I need to get through the theory part, so when we get to it, it kind of makes a bit more sense. So we're only going to discuss abstraction and encapsulation when it comes to the principles of OOP. There's 4 of them. Inheritance and polymorphism are also there, but they are lectures on their own. We're going to discuss that later in the module. So abstraction is data abstraction, procedural abstraction, which is methods. It's to abstract. So here is an example of information. Here, I'll come to the rest of the information. Do we need to have all this information? Full name, address, contact, tax information, favorite food, favorite movie, favorite actor, favorite band. Does a person need to know all of this? When working with just depends, correct? But if I just want to know the list of employees in my company, I actually just want this. So I abstract the information. I only show what is necessary to the person. And this is done through using private and public modifiers. So we abstract, we hide information away. Okay? So abstraction is about showing only what's necessary and hiding the unnecessary. So we reduce what a person can see or what a person can access by abstracting only what they need to see. So objects allow us to protect and control data. They allow us to protect and control methods by only giving access to what is relevant and needed. Also reduces complexity and effort, and is one of the most important parts of OOP by only exposing what is needed. Is everyone okay with abstraction? It's about exposing only what is needed for another person to see. I'm developing a class. I don't want a person messing with all of it. So I want to only let them access certain parts. So I allow that part, that's the abstraction of the data and the procedures. I only show them bits they need. The rest of it is hidden away, and we keep it hidden away. Does that make sense, ladies and gentlemen? Okay. How we do it is very easy. It's not hard, but we'll get to that again tomorrow. Right now, we're just focusing on the theory and trying to get this through it. Example of abstraction, a car. When you start your car, press the start button, turn the key, do you know what actually happens underneath the hood? Detail for detail. Or do you just care that it actually starts? Generally, we're happy when our car starts. That means there's nothing going wrong. Okay, the same for a microwave. Are we concerned on how a microwave actually works? No, we just put the pizza in or food in and just hit the button. That's abstraction. That's abstraction in real life. And it's done quite often. We don't know the nitty-gritty bits. We just know that if we do a certain thing, it will perform its task. Okay, now the next term we're going to look at is encapsulation. Now, encapsulation is bundling methods and data together that make sense. Okay, so we put things together that logically make sense, things that are meant to be put together. Also, it's about hiding. I actually want to skip to the pictures because it actually shows it a bit nicer. So here, with encapsulation, it's also partly abstraction actually. This is a light switch, by the way, if those who are not sure of it. Do we care about all the wires at the back here? Should we be messing with the wires in the back here? Or do we just want to see this, a working switch? Okay, so the combination of abstraction and encapsulation allows us to have just the switch. That it works, we can see what we need to see, we have access to what we need to see, the rest is hidden away. Okay, so let's go back to encapsulation. Encapsulation is bundling the right stuff, putting the right things together. If you're at the zoo, you expect the herbivores to be in one cage. You expect the carnivores to be in one cage or one area. Would it make sense for the herbivores and carnivores to be in the same cage at the zoo? It would be interesting to watch, it would be scary to watch, but it wouldn't make sense. I don't know if it'd be a funny show. Watching a 5-year-old watching something getting stalked might be interesting. Survival of the fittest, okay? So encapsulation is about grouping. They'll kill each other, that's the point. That's what I'm trying to get. Encapsulation is putting the right things together. The same way as medication. Remember, medication is encapsulated in a capsule. I'm trying to think of the damn right word. What is inside there is the right combination of medicine that will work together. The right compounds are grouped and bound together. In our cases, it's the variables and methods, the right combination that makes sense are encapsulated together, and then that's our class, our object. Okay, does that make sense? So it's grouping the right things together. There's a lot of like wordy sections here, I know, but also encapsulation refers to controlling access as well. Abstraction and encapsulation link similarly in the levels of controlling data. A good example, does the person at a bank know your PIN number? If they do, we have a problem. No, not depends, they don't know. If someone at the bank knows your PIN number, there's a problem. Okay? That is also what encapsulation comes to, is getting getters and setters. So we have hidden data. We've abstracted, we've hidden the PIN number, but would it make sense to have a PIN number but never be able to see it or change it? Okay, I'm going to repeat the question. Would it make sense to have a PIN number that you could never see and never use? Okay, that's where this term, you see, it's talking about getters and setters comes into. With classes and objects, we can control how something is obtained and how something is changed. So you have the ability to change your PIN, correct, for a bank. Can you, yeah, you can change it. Can you see it though? Depends on the bank as well. I know FNB will allow you to see your PIN. Can a person in the bank see or change your PIN? No. Okay, generally they can't. So we can control how things are seen and how things are accessed through classes as well. So it's also talking about protecting and securing our data. So this is also part of object-oriented programming. Okay, encapsulation is used to hide values or set structured data. Let me just say, set of a structured data object inside a class, preventing unauthorized parties direct access. So basically controls how things are accessed. Okay, says you can see it, you can change it, but no, you can't. Going back to Facebook, you have your friends, your family, and you set this person is a family member, this person is a friend, and you can control what they can see and what they can do on Facebook. That links to what we're doing now, how people can see and work with data. Okay, just want to make sure. Also, you don't want to, some part of encapsulation is hiding functionality. You don't want people knowing how your code works because maybe it's a copyrighted code, or it's a way that only your company or your group of people do that certain coding. So you can hide that code away and not let people see it. Also, you don't want people to change your code, which is important. Okay, a good example. When you take a picture, it's normally in a JPEG. The guy who developed the algorithm to rotate the JPEG made a fortune because he was the only one that wrote the algorithm. People could use it, but no one knew how he did it because he could do it without losing the quality of the picture, which was very unique at the time. Of course, he didn't go and make that public to everyone. He kept that to himself. So it's also, you hide it away. You let people use it, but you don't let them know how it works. The same as with the light switch. We know how a light switch works, but we don't know how it works behind the scenes. We know press it down or up, it turns the lights on and off. How the hell it works behind the scenes, I don't want to know. I'm not an electrical engineer. I don't want to mess with that. Okay, I got a friend, he messed with one light switch in his house, and every light switch then broke. So some things you don't mess with because you don't know what's going on. Okay, thing is, this is the part of coding we do. We write the code that's hidden away sometimes. We write the code that gets encapsulated, that gets abstracted. Okay, and that code could be how it connects to a database, how you interact with the database, how you encrypt information, how you decrypt information, things you don't want other people messing with. So we have to have mechanisms in place to enforce security and control around those. And that's what object-oriented programming allows us to do. It allows us to build in these protective layers, these methods that we can allow someone to use something but not know exactly how it works. Okay, like take Blackboard Colab. Blackboard Colab, it works sometimes. We don't know how it works behind the scenes. We don't really care as long as we can present the lectures and you can see the lectures and hear the lectures. That's our pretty much limit of caring of Blackboard and Blackboard Colab. Open source software is not encapsulated. Open source software is when people give you access and allow you to make changes. That's something else. But they will make use of principles of encapsulation, or they'll make use of object-oriented programming on a different way. That question, if I want to use someone to use my practical, you build an EXE. I'll show you that in a few minutes. I just want to make sure, is everyone okay with what I've covered? Because we still have a bit of time. We actually covered it quite quickly. I'm happy about that. What is your obsession with hackers, ladies and gentlemen? You have a real obsession. Okay, so Everyone okay with the idea of object-oriented hacking? Hacking isn't the bloody future. Okay, if you're hacking is the future, we're in for a bleak future. I said if hacking is the future, we're in for a bleak future. Oh yeah, okay. Let's get back to the actual content. We'll come back. Some of you are obsessed with it, yes. Okay. Now, is everyone comfortable with when we refer to object-oriented programming, we're referring to, instead of referring to logic and functionality, we're referring to data, an object, something that can represent a real-world entity, a real-world object in data. But it has data and it has methods. It can do something. Okay? Methods could be displaying the information, allowing access to the information, making calculations on the information, working out totals on the information. Those are the methods that could be inside the object. Okay, but the object itself has this functionality. It has its behaviors. Everyone okay with that? Okay. Also, you have to change the way you think, because now you are not just working in a single form anymore or single file. You're going to be breaking across multiple files. We will show you how to do that tomorrow as well. But you're not manipulating functionality, you're manipulating objects. Objects will do the work for us. Okay, so an object will go and display itself. An object will go and calculate a total for us. But we must give the object the ability to do it. I'll explain that in more details tomorrow in tomorrow's lecture when I show you how to make objects and I show you how to make classes. Okay, I will go in depth the difference between a class and an object, because they're different sides of a coin. Okay, again, this is another definition for object-oriented programming. But it's breaking it down into data and code. So an object has data and methods, code. It has the ability to act on itself. Okay, I'm going to get there again. Remember, object-oriented program also, it refers to about don't repeat yourself. It's about reusing code. It's a very, very important thing that we can reuse things. Abstraction and encapsulation. So those are the 4 principles of OOP, but there's also inheritance and polymorphism. Inheritance and polymorphism will be discussed, but they form like sub-lectures or subsections of the course itself. Abstraction, you have data abstraction and procedural abstraction. So this is showing what is important and showing what is needed. Let me say that better. Showing what is essential and hiding everything else. Showing methods that are needed and hiding methods that shouldn't be seen. Okay? It avoids people accessing things they shouldn't access. It avoids people going into things they shouldn't have access to. And it's a very, very important concept. The same way as we have all this information, but this subset isn't that important. What is important and what should be seen is this. We abstract the full name, the contact, and the tax information. That is made visible. The rest is not as important. We could technically hide it, but we'll get to how that's done later. Again, here's examples of real life examples of abstraction. Your car, your microwave, your motorbike, how your student card works getting access to campus. Okay, you know, if you swipe your card, give your thumb, or now just swipe your card, you can go in. It'll open the booms. What's going on behind the scenes, we're not too concerned of. With the microwave, we put the food in, we set the timer, we press start, and done. It should technically warm up our food. How it's doing it, no, we're not too concerned. Encapsulation is about grouping things together, grouping common things and common logic, common data, common methods together, and also hiding what should be hidden as well. Through using getters and setters, which we'll talk about. Those are referred to as property methods. Okay. Encapsulation also refers to mechanism restricting data access to some components, so they can't see or access particular parts. Encapsulation also hides data members and functionalities. So you can say, okay, only certain people can access certain areas of the code or access certain aspects. So we can encapsulate it and expose only what is relevant. Okay, someone raised their hand again. Question?
Good afternoon, sir.
Afternoon.
Sir, I would like to ask, since like this whole object-oriented programming approach is like to protect like our code, like once we we done writing the thing, we just want the user to have like the final product. So how do
That's
people,
something
like,
else.
yeah, how do people manage to like reverse the whole cycle after like the programmers have like gone through the whole process of trying to make people not to be able to access the code or like what's happening
We
behind?
will discuss it. It's known as a dynamic linked library, a DLL, where you package your code in such a way that it's usable, but not the code itself is not visible.
But people
We'll
still
discuss it
manage
later on.
to
Yes, you can. It's called reverse engineering.
Are we also gonna discuss that, sir?
No, we don't teach reverse engineering. That's partly, in some contexts, that would be considered illegal. If it's proprietary software, it could be illegal to reverse engineer. So we don't do that. Okay, ladies and gentlemen, remember, okay, let's get over this hacking and this illegal approach. Ladies and gentlemen, we're trying to teach you to become program or IT professionals. Okay, the same way a doctor is a professional, the same way a chartered accountant is a professional. We expect them to abide by a code of ethics and a code of conduct. I myself am a chartered IT professional. Okay, so I joke with you guys about hacking and all this, but I take a serious stance on when it becomes too much. I'm not going to teach you illegal things. I'm not going to teach you things that you shouldn't be taught. I'm trying to teach you in terms of an IT professional, someone that is responsible for what they do. This is going to turn into a bit of a quick lecture. Ladies and gentlemen, coding can have a serious consequence on life and how people function. If you make a mistake in code, you can kill people. Okay? People make mistakes in certain areas of code, they can injure people. So it's not something to take lightly. It's we're trying to teach you to be professionals in coding. How? Think of code that helps navigate a plane. There's been cases of planes crashing because the system assisting the pilot is incorrectly designed. So the plane crashes. You have the famous example of the one satellite going to Mars. That the guy decided, oh wait, I'm working in metrics instead of centimeters or something, and crashed the entire system. Instead of landing on the planet, it buried itself in the planet. A good point was brought out hospital systems. A system designed to control an incubator for a newborn. If you make a mistake with that code, you can kill thousands of babies in one go. if you're designing, if you're working on systems for hell, the worst thing I could ever think of is working in military, and you're designing algorithms to navigate missiles. One mistake there, instead of shooting the one person, you could kill a civilian. So you've got to take coding seriously. It is something that is got to be done properly. We're teaching you to be professionals, not to just hack for the sake of hacking. Okay, you get ethical hackers that are, and I have a colleague that is, his profession is a penetration tester. He works in companies to help secure them from hackers because of the problems they can cause. It's not something I consider as a joke or something lightly. It's a serious matter. So you get coding professions where their job is to help secure companies as well. And the principles we teach you is to, security can't be embedded after you develop something. Security has to be developed from the ground up. Even in AI, you've got to build it with ethics in mind as well, which is another thing we'll discuss later on. AI has to be developed with ethics in mind as well. Okay, now I've gone completely off track. Getting back to encapsulation. Okay, now encapsulation is grouping data and methods together. So you encapsulate it, you package it as one unit, and you work from there. Okay, so that's an example of encapsulation as well, and abstraction. The light switch is an example of both of them combined. We grouping things together that should be grouped together, and we only exposing what should be exposed in the correct manner, in a secure manner. Okay, there's 2 minutes left to the lecture. Any questions, ladies and gentlemen? I'm not going to go over time. Tomorrow's lecture will be discussing the theory and the, well, not the theory, the practical, how to make your own classes, how to make the objects, how to actually do that yourself. Okay, so we will tomorrow do a more practical lecture where I show you in VB how to make a class, how to make an object, and how to do that. Any other questions related to the theory point right now? Okay. Then I'm going to stop the recording, as that would be the end of today's lecture now.